So here we are, working on test correction for question number 7. You can see my paper, right? Perfect. Okay, so the problem reads, the owner of a sporting goods store plans to do a remodeling project 4 years from now. So he wants to invest money for the project. He will invest in an account that pays interest at 8% compounded annually. The project will cost $84,500 4 years from now. How much should the owner initially invest now so that he will have enough money in 5 years to pay for the $84,500 project? Okay, so we have a few different numbers here. So we have our 8%. We have do you happen to have your original test in front of you right now? Okay, cool. Let's do that because on the email that your mom sent, it says 4 years and 5 years in the same problem. So I just want to make sure that we get the right number because that's going to affect our answer. Yes, it's number 7. Okay, perfect. So we're working with 4 years. That's our time. Okay, so for this $84,500, is that our principal or is that our final balance? Okay, and what makes you say it's the principal? Okay, so normally in a regular problem, that's how we would do it. But if we actually read the problem and we sort of look a little bit deeper into what they're saying, I think the key sentence that tips this off is the project will cost $84,500 4 years from now. Then the problem says, how much should the owner initially invest now so that he will have enough money in 5 years to pay for the $84,500 project? So remember that word initially that we saw yesterday too? Do you remember what that means? Yeah, it's like at the beginning. So what the question is asking us is basically how much money does the owner put at the beginning? And the principal is the money at the beginning. So in this case, we're actually trying to solve for the principal instead of the final balance. Does that make sense? And in the problem, did you solve for the principal instead of the final balance? You're working on your test. Okay. Okay, you did try to solve for the principal. Good. Okay, well, let's run through the problem and see where you may have made a mistake. So we have our equation, 84,500 is equal to P, our principal. In this case, do we have to change our R and our N values, or are we okay the way that they are? I agree. And why are we okay with these R and these N values? That's exactly right. I couldn't have said it better myself. So let's go ahead and set up our equation. We have 84,500 P 1 plus R. And what's our R in this case? Changing the 8% into a decimal. And what would be our end value here? That's exactly right, because that's the number of years that we're going to let this money sit in the bank for. So if we roll through and start chugging along in our calculations, we start with 1 plus 0.1 plus 0.08, which gives us 1.08. If we put that to the fourth power, it gives us 1.3604. And remember, so now we have P times 1.36 is equal to 84,500. Now, in order to get this P by itself, what do we have to do to this 1.36? Okay, so you're on the right track. Remember yesterday when we did this type of problem, we said that we have to do the opposite of whatever's happening right here. And what's the opposite of multiplication? So let's take this number, or we can divide both sides. I'm going to write division as a line here, divided by 1.36. I'm going to write divided by 1.36. Or in our calculator, we're going to use the longer extended number with all of the decimals. So when we divide, basically what we do is we cancel these out, and that leaves us with P is equal to 84,500 divided by 1.36. And this is just something we can put into our calculator. So we have 84,500 divided by this. And I get the principal as $62,000, $62,110, and maybe 2 cents if you feel like that is necessary. So is this the answer? This isn't the answer that you got in your test, right? Okay. And so maybe it was just some sort of calculation error. Did you multiply 84,500 by 1.36 when you were doing the problem? Okay, so it was very, very close to this number. Okay, well, that could just be some sort of calculation thing, and that's something that just comes with more practice. Also, writing down every single step on your paper is going to help to make sure that we can sort of minimize those calculation errors. So, do you need any more time to write this down? Okay, cool. So that should do it with the test corrections. So let's start working on our next thing. So how do you feel about the last chapter that you worked on, the percent increase and percent decrease problems? Yeah, I think you did a really good job when we went over some of the questions on Thursday. So we can skip that and go on to the markup and markdowns, and we can go over this maybe before your next test or quiz. Do you have any sort of quizzes or tests coming up? Cool. I know you just had one, so that would be kind of messed up to have 2 in a row. So, okay, perfect. So this idea of markups and markdowns. So how are you feeling about this section so far? Yeah, that's a really good observation. It is very similar to the percent increase and percent decrease problems. It's just they sort of give it a different name. And in this case, the markup is really just a percent increase. But we just call it something a little bit fancy because we're talking about something specific. So were you using this equation here, this sort of percent markup is equal to markup divided by cost? Okay, so the amount of change divided by original quantity equals percent increase. That one? Yeah, awesome. So that equation totally works, and it's really saying the same thing as this equation down here. The numbers are exactly the same. It's just sort of giving it technical terms that you're going to see in different word problems. So let's go ahead and run through some examples for just markup. So let's say I have a shirt, and the cost to manufacture the shirt is $21. So the cost to make. And in order to make a little bit money in store, let's say Target sells the shirt for $32. Very expensive, very nice. So we'll call this the sale price or the cost. And what I want to find is the markup of the shirt. So, what would be my first step in solving this problem? Yeah, that's exactly right. And so, how do we go about doing that? And so, if we subtract 21 from 32, that's going to give us a negative number. So, we always do the bigger number minus the smaller number. So, $32 minus $21, which is equal to $11. So, this is our amount of change. That's the... Right, if we look at our equation that we had last time, that's our first number. And now we want to find the original quantity. Or, in this case, another way to say that would be the cost of the item. You said $21? That's exactly right. So, in word problems, they're going to call it cost, or sales price, or sorry, it's going to be like the cost to make or manufacture, or something like that. Usually they'll call this $32 the sale price, so cancel out cost there. And that's exactly right. And so now our equation right here, right, we're trying to find this percent of change, or the markup. So let's go ahead and plug into our equation. So what would we do with these two numbers right here? That's exactly right. So if we plug that into our calculator, 11 divided by 21. Yep, that's exactly right. So that answer looks good to me. Quick question. Can this number be greater than 100%? Yeah, and so what would, as an example, what would be a cost to make and a selling price that would make the markup more than 100%? Yeah, so if something, for example, like costs $1 to make and they sell it for $30,000, right, it's going to be way bigger than 100%, because 100% really just means we're doubling the price, right? So in this case, we can have a number that's greater than 100. That totally makes sense, just hypothetically. So let's go ahead and do another practice problem, just to make sure that we really nail this down. So let's say that my house costs $126,000 to make. And I want to sell that house for $310,000. $310,000. And I want to know the markup on my house. So what would be my first step in finding that? Our bigger number minus our smaller number. And that number is going to give us our markup in dollars, which is our first step in finding it. So let's go ahead and plug that into the calculator. 310 minus 126,000. I got the same thing. $184,000. Exactly. Our smaller number when we're talking about percent markup is going to be our original quantity or original price or something. In this case, this 184,000 is our amount of change. And what's going to be our next step to finish up this problem? That's exactly right. And so let me know when you get an answer once you do this division. Okay, and so I think, so in this case you told me that we did $184,000 divided by $126,000, right? And so another way to write this right here is $140,000 divided by $126,000. See, my number on top came to the right. Or to the left, excuse me, and the number on bottom came to the right. And when we have division like this, what number do we plug into our calculator first? The one on the left or the one on the right? So let's try doing the calculation again. We plug this number in first, and this $126,000 in second. So let's call that 1.48. And what's our final step to make this answer a percentage? Yeah, that's exactly right. 148%. And does this answer make sense? Yeah, okay, definitely. I agree with you there. Another thing to notice is it's over 100%, and what does that mean about the cost and the selling price? Yeah, it doubled, or if it's more than 100%, it did a little bit more than doubled. So if we do 126,000, or our original cost times 2, we see that the number that comes out is $252,000. And so if we double our original price, the selling price is greater than that, so it makes sense that our answer would be over 100%. Not something that you necessarily have to do for every single problem, but I just want you to sort of see the different ways that we can potentially check our answers. Does that make sense? Awesome. Do you have any questions about this sort of problem in terms of markup? Yeah, every single time. So in this case, when we have this amount of change, this division symbol in original quantity, we're always going to put in our top number first, and we're always going to put in our bottom number second. So, and our amount of change is always going to go on top, and our original quantity is always going to go on bottom when we're solving this kind of problem. Does that answer your question? Cool. So for example, if we had, hypothetically, if we had 184 divided by 60, which number would go in our calculator first? Another way to write this would be 184 divided by 60, and we'd get some sort of number. If we had 120 million divided by 5 million and 1, which number would go in our calculator first? Doesn't matter how big or small the numbers are. What matters is that the number on top goes in first, number on bottom goes second. Does that make sense? Cool. Alright, I think we have time for one more practice problem. Just nail this down. You're doing really, really well in this, and I'm really, really glad that this is clicking for you. Because I know the compound interest is really, it's pretty difficult, and I remember struggling with it too when I was younger. So it's good that we're finding our stride here. Okay, so let's say that I bought... Do you play video games at all? No? Okay. Well, let's say we bought a baseball. Or the cost of a baseball to make is $4. And the selling price is $9. And I want to find the markup on this baseball. So what would be my first step to solve this? And what comes out when we divide that? And are we done? And that's exactly right. Awesome. So